Welcome to the Angeles Corporation PIC Wire and Cable webinar. Today we are going to talk about the optimization of interconnect components within 10 gigabit aerospace applications. Let me start off by introducing the key speakers for today's webinar. My name is Mike Lobus and I am the Technical Sales Manager at the Angeles Corporation. I lead the technical sales team in servicing our customers by understanding their connectivity needs and matching the Angeles Corporation solutions to those needs. Prior to joining Angeles in 2014, I have 15 years of sales and management experience serving as a field sales engineer and a general sales manager. In front of that, I have 9 years of contract management, electrical design, and systems engineering as a member of the Boeing Company. I hold a BS Electrical Engineering degree from the University of Alabama in Huntsville. Paul Deek is the Chief Operating Officer at the Angeles Corporation. Paul leads the company's development activities and serves as the business manager for our engineering services and new product development activities. Prior to joining Angeles in 2015, Paul had success at Rockwell Automations, holding various leadership roles within engineering and operations. Paul holds both an MBA and an engineering degree from Marquette University. As far as an agenda, I'm going to go over some of the emerging technologies that we see being implemented into aerospace and defense platforms in both military and commercial applications. Then I'm going to touch on how these technologies are creating the need for higher data rates and increased bandwidth, mainly 10 gigabit systems. At that point, I want to summarize some of the infrastructure challenges that high-speed Ethernet creates and go over some of those considerations for 10 gigabit data transmission. At that point, I'll hand it over to Paul. He is going to introduce our new 38999 10 gigabit connector called MachForce. He's going to provide the feature set of the connector and how it is addressing the high data rate infrastructure needs. Finally, Paul is going to conclude with a company overview outlining our PIC wire and cable products and other services. This is an exciting time in the aerospace and defense industry as we navigate what the future might look like. The aerospace and defense industry is driving technology to reimagine the future of flight, how people are moved, and how communications occur at 30,000 feet or beyond. These technologies are being implemented today in areas such as connected aircraft, autonomous aircraft systems, and virtual environment. Let's touch on a few of these technologies. Artificial intelligence and machine learning. Artificial intelligence is not a new concept, but is beginning to be widely adopted and implemented. AI's developed has significantly accelerated over the past decade, largely due to three factors. We now have capacity to collect and store massive amounts of data. We have increased computing power, and we have developed powerful algorithms. The use of AI can increase speed, efficiency, workload, and safety to enable more complex technology like autonomous vision-based navigation and data ecosystems. Artificial intelligence is also a platform for future innovations like unmanned aircraft. Unmanned aerial vehicles, UAVs, now make up a huge component of any operational effective military anywhere in the world. With systems defining absolute and true position of the aircraft, the need for better sensors and connectivity is imperative. The technology continues to develop for the military and will also migrate into commercial applications. Right now, most aircraft avionics systems are built around technology that provides data to the crew for adjustment or correction. Future avionics systems will rely heavily on software that can provide motion planning and trajectory prediction data. Using the automotive comparison of automatic emergency braking now installed in cars, avionics systems of the future will rely heavily on predictive analysis integrated with sensor fusion. This allows systems to recognize events in real time and make routine, non-routine, and emergency flight corrections. The tactical control systems that are being developed rely on protocols that integrate an architecture which allows for less reliance on the human element. Obviously, the need for autonomous operations with human oversight won't be fully effective unless the aircraft environment can be correctly simulated in real time to the human interface. A new technology will evolve to aviation is simultaneous localization and mapping, or SLAM. Essentially, the concept of SLAM is the instantaneous translation of data from the real world via sensors into the virtual world for processing actions and interface. Secure communications and increased computing capabilities are already driving war-fighting efforts. And like most technologies which are developed for the military, radar as an example, it won't be long until the technologies end up in a commercial application. Current aircraft computing and connectivity systems are getting more complex. As the threat of worldwide communication breaches expands, the threat of hacking an aircraft system continues to increase. It is imperative that the data transfer is within a completely secure manner. As cybersecurity threats increase, it is reasonable to predict that avionics and in-flight entertainment systems of the future will deploy counter-hacking technologies. In addition, it would be easy to connect avionics of the future with onboard servers equipped with firewalls and security protocols. With the advent of onboard Wi-Fi, in-flight entertainment and connectivity systems delivering high-def video, GPS data, and satellite content streamed directly to passenger seats, as well as newer avionics systems in the cockpit, there is already a strain on existing aircraft connectivity networks. The common denominator of all these technologies is that they require extensive amounts of data to be processed. As more data is processed, there's an increasing need to heighten the data transmission rates to new levels within the aircraft. Any additional new avionics systems will only further increase demand and dependence on computer servers and demand a need for higher speed connectivity and bandwidth requirements. As these emerging technologies are implemented, system designers and aerospace engineers consider several options as the backbone of their connectivity solution. Solutions require infrastructure that can accommodate increased data rates and more throughput, increasing the total bandwidth of the system. A growing option is 10 Gigabit Ethernet, which can support current mission critical functionality while offering room to expand and growing data requirements. Ethernet has arguably been the most widely integrated network infrastructure protocol in aerospace and defense applications over the last 2 decades due to the open source architecture and exceptional reliability. With the introduction of 10 Gigabit Ethernet in 2002 and the embrace of the technology over the last 10 years by major internet service providers, the technology is poised to challenge traditional Gigabit Ethernet as the most widely integrated Ethernet standard in aerospace and defense applications. Typically, servers and switches using 10 Gigabit Ethernet for networking communications are connected by either copper or fiber optic cables. Fiber optic cables, although suitable for some applications, create challenges when being integrated into existing airframe architectures. Integrating fiber optic cables requires special handling and tools, as well as a highly skilled and certified installers. Fiber optic cables also have limited flexibility, making system installation challenging and presenting risk for future repairs and maintenance. We have found that many aerospace and defense customers are choosing 10 gig base T copper cables to support the higher frequency required for 10 gigabit transmission over long distances. Copper cables tend to be a preferred solution in many applications due to the successful history of Ethernet copper cables in avionics environments. Given their years of experience integrating copper in Gigabit Ethernet applications, aerospace engineers are comfortable incorporating 10 Gigabit Ethernet via Cat6a and Cat7 cables. 10 gigabit data rates require an efficient connectivity infrastructure to eliminate signal loss and crosstalk, maintaining signal integrity through the aircraft or ground vehicle. PIC Wire and Cable is addressing this need with cutting-edge Ethernet cables and connectors. PIC Wire and Cable offers Cat6a and Cat7 cables developed specifically for applications requiring flexible, lightweight, low loss, and high temperature solutions in rugged aerospace environments. PIC Wire and Cable is also addressing the need for increased connector density and signal integrity through bulkhead connectors with our new 38999 Mach Force connector series. With that, I will hand this over to the Angeles Corporation Chief Operating Officer, Mr. Paul Deek.
Thanks, Mike. As the industry has migrated to connectivity solutions with higher signal processing bandwidths, PIC Wire and Cable is developing solutions to meet those challenges. PIC has developed the new MachForce family of connectors that are certain to change the way engineers think about copper-based interconnect solutions. So let's break down the new MachForce connector family a little differently. Let's break down the offering based on challenges in the industry. Let's start with size or product density. In the aerospace and defense industry, OEM solutions are constantly battling the need to add more functionality while keeping the physical footprint of the solution small and lightweight, while maintaining the product's robustness. The MachForce product has been optimized to provide 10 ports of Ethernet in a standard D38-999 size 25 connection. Most premium connectors are able to get 7 or 8 ports into their size 25. Again, MachForce's proprietary design allows for 10 ports at size 25. In fact, the standard D38-999 products that use a discrete wire design are only capable of getting around 4 ports in a size 25. So in some cases, as a designer, you may be able to replace 2 or 3 of the other company's size 25 connector with only one MachForce size 25. Now that allows you to reduce the size of your chassis, and a one connector solution will certainly be lighter than 2 or 3 connectors. Similarly, the new MachForce size 17 connectors allow for 4 ports of Ethernet. Most connectors allow only 2 ports through their size 17 connectors. Again, reduced number of connectors means a smaller final product at a reduced weight. It's important to note that while the design offers best-in-class density, the robustness of these connectors has not been compromised. MachForce passes all the D38-999 shock and vibration requirements. The connector's performance has been qualified at temperature extremes of -60 to 200 degrees C. When coupled with the PIC Wire E6A 6824 or E6A 6826 cables, which have also been qualified to 200 degrees C, you have an extremely robust, high-speed data interconnect solution. Both the RoHS black zinc nickel and the olive drab cadmium plating options meet the corrosion resistance limits. When your application needs a water-sealed solution, both the MachForce connector bodies as well as the straight and 90-degree back shells meet the IP67 water ingress protection limits. Next, let's address high-speed Ethernet performance and signal integrity. The truly unique portion of all MachForce connectors is the patented high-speed module. This uniquely designed module provides not only the high-density solution with its linear design, but it also enables the connector to maintain outstanding signal integrity. Looking a little closer, you can see the unique elements of the design. Note how every twisted pair is allowed to maintain its twist right up to the pin or socket. Note the rib design of the high-speed module, which allows for each pair to remain isolated from the next pair when the individual pair's shielding is stripped back. Under the clamping mechanism of the high-speed module, the cable shielding is pulled back and grounded 360 degrees to the high-speed module itself. When the high-speed module is inserted into the MachForce connector body, that grounding is passed to the connector body. As MachForce connectors are mated with each other, again, the grounding is maintained. All this contributes to better isolation of the twisted pair signals. Even the material selection of the plastic that holds and guides the pins and socket has been selected to ensure outstanding signal integrity. The dielectric constant rating of the plastic helps keep interference from the pins and sockets. Just one more example of the outstanding high-speed module design is the printed circuit board connector. The high-speed module has intentionally been designed to protrude through the printed circuit board in order to maintain as much signal isolation as possible. So what does this all mean? Simply put, the Mach-Force connector with its patented high-speed module, combined with a robust pick-wire Ethernet cable, allows for application teams to stretch previous application limits. For example, Mach-Force connectors can maintain 10 gigabit signals at lengths of greater than 270 feet when used with a pick-wire 24-gauge cable. Equally exciting is the fact that Mach-Force's insertion loss is so low at the connector, you can now design connector breaks into your system while still maintain 10 gigabit performance at those long lengths. For example, we designed a 24-gauge assembly with 5 unique Mach-Force connector breaks and performed the standard Cat6a signal test and passed that test at lengths greater than 270 feet. Mach-Force connectors now allow designers to utilize a robust copper solution and perform at a high speed 10 gigabit data rate at long lengths while still maintaining multiple disconnects into the solution. Exciting results. A third challenge for the industry that Mach-Force improves is termination ease. Many premium D38999 connector solutions offer such difficult wiring termination that terminating, say, one size 8 contact can take well over 30 minutes. Again, due to the unique design of the high-speed module, an experienced technician can terminate a Mach-Force connector in a much shorter period of time. Now, we all know that configuring this many cables into such a small space is never easy. However, the Mach-Force connector design has significantly improved this effort. We utilize standard, crimped 22D sockets and pins as part of the design. No special tooling required, and the pins and sockets are not so small that they can easily be bent or damaged. For that matter, many competitors use such small pins that a technician can barely even work with them. The Mach-Force termination allows a technician to build up one high-speed module at a time and then snap the high-speed module assembly into the connector body when finished. It may not be easy, but we certainly have simplified the process. This unique design allows for another Mach-Force solution to an industry challenge: field repairability. Most competitor products are very difficult to terminate, but nearly impossible to repair after final assembly is complete. So as an example, your application starts to develop an intermittent signal issue. You check the integrity of the cable and believe there's no issue. The next logical step is to inspect the terminations at the connection points. So let's walk through just how easy it is to repair a Mach-Force connector. To disconnect the two mating connector bodies, we've developed an innovative anti-decoupling ring. Simply pull back the ring on the plug connector and you should be able to begin loosening the coupling nut. We intentionally designed the ring to have a larger OD so that a technician could easily disconnect the mated connector even with a gloved hand. So now the connectors are disconnected. Loosen the back shelf from the connector body, and if it's a sealed connector, slide the sealing plug back several inches in the cable to give you some room to work. Now to the elegant part. Simply depress both side tangs of the high-speed module and back out the module from the connector body. You now have the ability to inspect all of the twisted pairs. If one is damaged, you can pop the pin and socket off the high-speed module, potentially recrimp the cable and reseat the wire in the module and reassemble. No special tools required. The standard 22D pins and sockets. Mach-Force's patented high-speed module design is a true game changer. Outstanding signal integrity, outstanding density, easy termination, and field repairability that protects your initial investment and allows a technician to repair on-site without significant training or expertise. It's also worth noting that Mach-Force's printed circuit board connector, which utilizes a very similar high-speed module concept, is also repairable. Our hope and expectation is that repairing a Mach force connector on a printed circuit board assembly will be very rare. However, the PCB connector has been designed to be easily disassembled to allow for pins to be replaced or resoldered if necessary. So the final challenge in the industry is a bit more generic but very real: product availability. We are now stocking all of the released products for the Mach force portfolio: jam nut, flange, plug, PCB configurations. Products are available for sample now, including both size 25 and size 17 connectors and their corresponding backshells. We have multiple plating options and 24 and 26 gauge cable sealing solutions. We also have stock in the 5 different keying solutions in alignment with the D38999 standard. This part number builder is available online at pickwire.com. We have only just begun. Our plan is to continue to roll out more unique products over the next several years. We are also planning to qualify different PICWire application cables within the Mach force solution, such as USB, USB-C, HDMI, DVI, etc. Look for more information on signal integrity characteristics for those solutions on Mach force shortly. More possibilities are on the horizon. Bring us your challenges: different connector sizes, different cable types, different configurations of cable bundles. We are ready to assist. In 2021, we are very proud to celebrate PICWire and Cable's 50th year in business. For 50 years, we have been helping make our customers' job easier. We have the technical expertise to assist you and your team through your most difficult interconnect challenges. Whether your industry is military, corporate, or commercial, we have technical solutions to improve your systems. For applications that include airplanes, helicopters, UAVs, ground vehicles, rail transport, marine vessels, we have solutions to meet your most difficult challenges. Please feel free to contact PICWire at 1-800-742-3191 or submit your question via our website, pickwire.com, and one of our sales team members will be happy to assist you. Our hope is that you found this information worthwhile. Thank you very much for your time today, and we wish you all success in the near future.
Thank you so much for that great presentation, guys. And now let's get to the Q&A. We have some questions that have come in from the attendees, so we're going to move into answering those now. If we don't get to your question, don't worry, we will have an answer for you following the webinar. If you haven't submitted your question yet, you can do so now by entering it in the Q&A box and clicking submit, and we'll try to get to it before the close of the session. Okay, now for our first question from the audience. What market or customer input did the Angeles Corporation get to develop the Mach force solution? Guys?
I'll take this one, Mike. This is Paul Deek again. We spent some time interviewing dozens of customers as part of our extensive voice of customer leading up to the Mach force development. These customers included military applications, corporate aircraft manufacturers. We talked to companies making OEM solutions or actually the vehicles or the land vehicles themselves. And it was a great experience that lasted quite a bit of time. Basically, we heard loud and clear that things like repairability, that ease of termination, product density, they wanted more product in a defined space. And one of the loudest that we heard was outstanding electrical characteristics to allow that 10 gigabit type of performance with the multiple disconnects. So it was a fairly extensive voice of customer experience that led to a detailed product specification. And we're really quite proud of what the product became as a result of that dialogue, because we are certain we solved the majority of the customers' requested challenges. So that was a good question. Thank you, Matt.
Excellent, thank you. And I just want to remind the audience, we are now in the Q&A session. We have our experts online and ready to answer your questions. Please send them in by entering them in the Q&A box and clicking submit. Okay, now for our next question from the audience. What details can you share on your MachForce product roadmap?
Another good question. So today we have our size 25. We have multiple plating options and multiple backshell options. We also have our new size 17, which is our 2-port option, our 2 Ethernet port. As I mentioned in the body of the webinar, our intent is to continue to approve different application cable types as part of the MachForce configuration, whether that be HDMI, USB, DisplayPort. So we'll be running some signal integrity and some performance tests to make sure that we provide the right level of quality and the right level of output for those other applications. Beyond that, we actually plan to offer more sizes, size 9, size 13 type of solutions for MachForce. But most importantly, really what we're looking to do is we're looking to follow where our customers want us to go. So if our customers ask for us for a unique configuration, a unique product, we will certainly investigate it. Obviously, there's got to be some return or some volume associated with it, but we're very much in the innovation or the design phase of this portfolio. So if our customers have some unique applications, some unique challenges, I look forward to MachForce being adapted to provide those solutions in the future.
Excellent. Thank you for that. And now would be a good time to remind the audience that across the bottom of your screen, there are several buttons that you can access, some of which have additional resources. In addition, there are several ways that you can reach out to the PIC Wire and Cable team. So please engage with them, get in touch. They would love to hear from you and continue to build and find those great solutions. Okay, moving back into the Q&A session. Okay, here's the next question from the audience.
Don't go to that question yet.
Okay. Is the MachForce connector installed on any airframe today?
We actually have several. Sorry, go ahead, Mike.
Yeah, this is Mike. I can answer that question. Yes, the answer to that is yes. We have it on a few platforms right now. We actually had what we called a launch customer, which worked with us as we developed it, and that is on a C-130 aircraft, and that connector is on that aircraft, and they have that aircraft out in the field now. We've also are on a King Air 350 on another ISR type program, and we're very close to getting integrated on future helicopters and other aircraft, for example, a 737.
Wow, very cool stuff. Thank you for that. Okay, and we had a few folks sending some thank yous, also some questions about whether or not they can rewatch the content. So first of all, thank you very much for the thank yous. We love that you're here. In addition, this content will be available in an on-demand replay state approximately 1 hour after the live session ends. So you can come back and watch this again or share it with your colleagues. Okay, back to the Q&A session. Okay, here's another question from the audience. You mentioned the dielectric constant of the plastic material of the connector. Can you share the approximate value or range of the dielectric constant, and why is that so important?
So I'm not the development engineer. It's a great question, and I can get the actual plastic material type. I'm here looking it up. But really what we're trying to do is we're trying to have that plastic material that holds the pin or the socket. Remember, the way the high-speed module is designed, the pin is nested in a piece of plastic, and it's actually, there's an insulator that slides over the top of it. And in effect, that dielectric constant of the plastic acts as a shield, further protecting the electrical isolation, keeping your signal integrity high.
I can look up and get back to the particular individual who asked the question with the actual material type that we use, but really the idea is to continue to maintain that signal integrity, in effect isolating the twisted pair of the signal itself, so that there's really no chance of either the radiated signal or the signal coming in from an immunity perspective. So again, that's why the dielectric is important. The dielectric constant of the plastic is important during the manufacturing of mock force.
Excellent, thank you for that. And I just want to remind the audience, you can submit your question by entering it in the Q&A box and clicking submit. For now, we have one more question in the queue. So here it is. How did you determine which D38999 test to perform when qualifying your product?
I can address that one as well. And so we wanted to qualify as much of the D38999 specifications as we could on our product, and we did so. So from shock and vibration to signal integrity to corrosion resistance to the temperature tests, we went through the entire suite of the D38999 requirements and qualified mock force. Because of the density of the mock force design and the linear configuration, we had to make sure that we met the cutout responsibility, or the cutout of the D38999 space. And I'm happy to say both size 17 and size 25 meet the standard D38999 cutouts for both size 25 and size 17. So the product is fully qualified against the requirements for 38999, and I'm quite proud of the end result.
Excellent, thank you for that. And we do have another question that came in. So here it is. What type of assembly or termination capability does the Angelus Corporation offer?
Good question. So as we stated, our mock force connector has been dramatically simplified in how we terminate it. But the reality is it's still, when you're putting this much Ethernet or this much cabling into a small connector space, it still can get complex. So Angelus has the ability to manufacture not just Ethernet type solutions for mock force, but coaxial cable, high frequency cable connections, that type of thing. We have all that capability internally ourselves. So if you're interested in mock force, but if you find the termination a little challenging, that is absolutely a service that we as PIC Wire and Cable and the Angelus Corporations provide for you. So instead of just simply quoting the connector, you can quoting the connector and the assembly, and that's a service we certainly provide.
Excellent, thank you. And we have some more questions coming in, which is amazing. Thank you so much, audience. Please keep sending those questions in. Like I said, the experts are here and ready to answer you, so send us your questions. Okay, here we go. Next question from the audience. Is it ground 360 degrees in the HSM?
Right. So when you feed the cable through the high-speed module, part of the termination instruction is you actually pull the shielding back off of the twisted pairs as it comes through the high-speed module. And there's a clamping mechanism on the high-speed module. That shield is actually grounded 360 degrees at that clamping mechanism. Again, providing the grounding capability, if you will, the isolation that's necessary to maintain the signal integrity. So yes, there's 360-degree grounding of the cable shield at the clamping mechanism of the high-speed module.
Excellent, thank you. Okay, and next question from the audience. Do you expect to support Ethernet through mock force connectors at some point beyond the current 10 GE rate? I think that might be GB, gigabit.
Yeah, I think 10 gigabit rating. And so there's a lot of application-specific type of nuance to that question. So the farther you go with a cable, the harder it is to maintain a high bandwidth or a high data rate. So if your application is a lower length application, you certainly can get higher data performance than the 10 gigabit. So really the question comes down to our cables are the best in the industry as far as our Ethernet performance and the signal integrity. But if applications would allow for you to go even faster, my point there is that you may have to shorten up some of your cable lengths to get to, say, a 40 gigabit type of performance, which is possible with the Mach-Force connectors and the right cable selections, but maybe not at the 270 feet that was quoted for the 10 gigabit.
Excellent. Thank you for that. And it looks like that was our last question, so we're going to wrap things up right there. Guys, thank you so much for taking the time to be with us today and taking the time to answer some questions from the audience. I'd like to also thank our audience members for being part of this webinar event.